Two and a Half Admins, episode 162. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. Let's do some news then. The first is just a quick shout out for opensource.net. We talked about the demise of opensource.com, but they're back as opensource.net now.
Yeah, and honestly, I don't have too much to say about that other than that website is back, and that's a wonderful thing. If you're not familiar with what opensource.com was and opensource.net is, in addition to being a kind of news and generally like story/documentation site where you can see people talk about the things that they're doing with open source and the challenges they've faced, you can very easily be one of those people whose articles is there. It is a very community-focused site, and they specifically are looking to get community voices. Now, this is not something that will get you money, but it's very easy to reach out to their editing team and, get helped through the production of a successful, high-quality article, which if you have any aspirations to be a published writer, it's gold. You need to be doing that. Get in that pipeline, get your stuff published, get some practice learning how to write well enough to be published. You can't beat it.
Yeah, like at Clara, when we're looking for people to write articles for us, we want to see some samples of what you've written before. And so a site like opensource.net where you can say, here's some stuff I wrote before. Obviously, that involves getting help from an editor and everything. It really helps build your kind of portfolio and get you started in that path.
All right, let's talk about the vulnerability in libwebp. This was not handled well by either Google or Apple.
Not at all.
No, it was not. The vulnerability itself was bad enough, but the very incomplete disclosures from both Apple and Google led to the scope of the vulnerability not really being understood anywhere near as quickly as it should have been. Both Apple and Google treated it as though it were just a local problem and not a problem in a widely used library. And that made it take a little while longer before people realized all the things that needed to be patched.
Yeah, basically Apple said, oh, it's a bug in ImageIO, and we fixed it. And then Google's like, it was a bug in Chrome, and we fixed it. And neither of them bothered to tell anybody that actually the vulnerabilities in libwebp that we pulled into our application. And so that means every application that pulls that in, which is a lot of them, is now vulnerable. And, that open source project is not even aware yet.
It seems really strange. I mean, I get that Google and Apple between them basically have hired all the developers, but why would you want to monkey patch an upstream library locally for your thing rather than, even if you're going to write the code to fix it, upstream that? Why would you want to maintain that forever yourself when that's not actually your project?
Well, it depends if their plan was forever. Sometimes I've seen companies decide that they want to get their fix out the door and have their customers be patched before they disclose to anybody what was happening. Basically the opposite of the organized disclosure we normally have, or coordinated disclosure.
Yeah, responsible disclosure is to talk to people on private mailing lists and stuff and get it all sorted together.
Yeah, and it seems their plan was maybe we'll do that after we've already shipped the fixes for our users, because this is being actively exploited by nation states, but it's a really bad look for both Apple and Google on this one.
Whether anyone there would articulate it that way or not, I strongly suspect that a feeling has kind of grown around companies of that size that responsible disclosure is what you expect from researchers that report your bugs to you, not something that they need to practice themselves.
If somebody reports the bug to you because it affects your application, you could bother to check and say, hey, this is actually not in our code, but in something we pull in from an upstream. We should bring them in on this. And it seems they didn't. So the bug was originally found by Citizen Lab, which is a research group at the University of Toronto's Munk School. And they specifically work on trying to protect dissidents and other at-risk groups from nation-state type attackers. And so they look for things that can be exploited in a browser to compromise somebody's computer. And they reported these problems, but while trying to be responsible, ended up it not getting to the right people. Eventually, we did get a new CVE number for the same bug, which is also kind of interesting.
Yeah, we ended up with 3 CVEs for this.
Which is absolutely also a problem. It makes it a lot more difficult to track what's going on.
Exactly. And the fact that the first 2 didn't say it was about WebP.
Even if you're aware of all 3 CVEs, if you were tracking the impact of that specific flaw and its mitigations, you now have 3 different CVEs you've got to keep on top of all of them because you don't know where reports of issues are going to come in or be referenced. So it just, it's not good. We already used the term responsible disclosure. This just doesn't seem to have been very responsible, in my opinion.
They say, since the vulnerability is scoped under the overarching product containing the vulnerable dependency, the vulnerability will only be flagged by vulnerability scanners for those specific products. This creates a huge blind spots for organizations blindly relying on the output of their vulnerability scanner. So, the scanner is going to check Chrome and Image.io and say, oh, those are patched, and not bother checking all the things you're using that use WebP that are still vulnerable because there wasn't a separate CVE for it until after. And so Google in particular has come under criticism for limiting the scope of the CVE they registered to say this only affects Chrome when obviously the problem was in libwebp, which is beyond just Chrome.
It seems difficult to come up with a scenario where you wouldn't realize that also.
Even if they're just vendoring in a copy of WebP or whatever, it's like, how do people solving this bug in Chrome and Image.io not realize that this is upstream code and we should at least in the CVE mention that this is a bug in WebP? So the Google representative says, many platforms implement WebP differently. We do not have any details on how the bug impacts other products. Yeah, but if most platforms actually use libwebp the same as you do, while some people might do it differently, a lot of people do it the same way. That doesn't absolve you of actually reporting this to people.
I suppose that raises the question whether Google and Apple are actually still tracking the upstream code at all, or whether this is a form of, I don't want to ascribe too much evil motive here. Don't interpret it that way, but this could be a form of embrace, extend, extinguish, rather than forking the library, but, tracking upstream and pulling things in from upstream. It could be an instance of just going, okay, well, we have our local version now, and we don't care what upstream does with theirs because we're Google and we make all the browsers of the world now that everybody's using Chromium. So, our libwebp is actually the one that matters. And if you want to use that other one, it's on you.
Yeah, it just seems like that would mean any fixes that go into the other libwebp, you'd have to manually manage yourself. And
you would, but for an organization the size of Google, there is a very legitimate question as to who has more people working on that code, the actual upstream project or Google developers.
Yeah.
I don't think there's an easy, obviously this is the answer to that. I think you'd have to do research to answer that question.
And it might well point to the perennial problem with open source, that there's just not enough money going into the actual underlying bits, as we found out with Heartbleed and that classic XKCD comic with the one little pillar holding up the whole structure.
Or for the other side of the same coin, remember LeftPad?
I think it's important to understand quite how widespread this issue is. It's not just the browsers, it's anything that touches libwebp, which is, it turns out, quite a lot of different bits of software.
Well, sure, and it's just about anything that touches data from the internet one way or the other, because more and more of the images on the internet are WebP for, the higher compression. One obvious snarky comment, which frankly I already made off air, was great. Like I needed another reason to hate WebPs, but the tooling around them is very limited compared to GIFs and JPEGs and what have you, which is why they annoy me so much.
GIFs.
But it's the flip side is that given that there is so little tooling, pretty much all of the tooling involving dealing with it is libwebp based, and anything that deals with images on the internet is probably going to have to be able to deal with WebPs, because increasingly that's what all the big content mills are using for its technical advantages.
Yeah, just looking at the list here, Basecamp 3, Discord, Keybase, Mattermost, Microsoft Teams, Mullvad, isn't that the VPN?
Sure is.
Why does the VPN use WebP?
Well, anything that uses Electron is potentially vulnerable.
Notion, Signal, Skype, Slack, Twitch, Visual Studio Code.
Like I said, anything that touches the internet.
Yep.
And especially anything that uses Electron. A lot of those are Electron-based.
Ropes in a whole lot of mobile apps, too.
Yep. They also say beware of false negatives. Turns out some of the vulnerability scans will incorrectly say you're fine when you're not. I think the real solution to this problem is something called SBOM, or Software Bill of Materials. And that's where products like Chrome and even open source things or appliances or whatever would have a software bill of materials, which would list all the libraries and stuff used inside that application and the versions, where we would be much more able to tell, hey, this program happens to use libwebp, this version that's known to be vulnerable to this CVE, instead of people having to self-disclose, oh yeah, Discord happens to use that too, and having separate CVEs and stuff.
You have to love that the acronym for the software bill of materials is essentially shit bomb. What's in that thing? Open up the shit bomb if you dare.
I forget the name of it now, but there was an attempt to have a more unified way of telling if a CVE applies to something. I remember the FreeBSD port tree grew it, and it was basically this string that described the software and the version and a couple of things where you could actually do programmatic matching of, is this version of this program actually going to be, match against this CVE or not, to make it much easier to scan, not for the vulnerability, but just knowing what software is installed on a system and which CVEs may or may not apply to it, without having to rely on a human manually checking the hundreds of applications that are likely, especially when you consider every library that might be installed on their system.
This is one reason that I've been railing against containerized applications for a very long time now is, when you install something from a native package, you immediately see all of its dependencies. When you install Snap or Flatpak or whatever, well, you just got whatever the hell you got. You might as well be installing proprietary software for all it really tells you about what's in there and what you need to be worried about if you're looking at CVEs. If you're using a Linux system that's got nothing but native packages, no snaps or no Flatpaks, and you learn about this vulnerability, you have one thing you need to check. What's the version of libwebp installed on my system? If you're using containerized applications, you need to think about every single one of them that might potentially have some version of libwebp in it and worry about what version is bundled in it. You're not going to see that just from looking at dependencies on your system, because technically that's not a dependency on your system. It's just been hoovered up and bundled straight into that particular code base, just like what they do in the proprietary world. And you get little or no notification about what's in there, just like they do in the proprietary world.
Okay, this episode is sponsored by Kolide. If you work in security or IT and your company has Okta, this message is for you. Have you noticed that for the past few years, the majority of data breaches and hacks you read about have something in common? It's employees. Hackers absolutely love exploiting vulnerable employee devices and credentials, but it doesn't have to be this way. Imagine a world where only secure devices can access your cloud apps. In this world, phished credentials are useless to hackers, and you can manage every OS, even Linux, from a single dashboard. Best of all, you can get employees to fix their own device security issues without creating more work for IT. The good news is, you don't have to imagine this world. You can just start using Kolide. Kolide is a device trust solution for companies with Okta, and it ensures that if a device isn't trusted and secure, it can't log into your cloud apps. So support the show and visit kolide.com/25A to watch a demo and see how it works. That's KOLIDE.com/25A. Let's do some feedback then. Charlie says, just finished the episode where you talked about the demise of 2.5-inch hard drives and how they can't compete with the density of 3.5-inch nor the speed of SSDs. Would there be any advantages to a hard disk drive physically larger than 3.5 inches? I assume the latency would be extremely high, but perhaps that would be offset by their density. Do they exist? If not, why not?
To the best of my knowledge, they don't exist, and I can tell you exactly why they don't exist, because the larger the platters get, the flappier and flimsier they get, and therefore the lower quality of media you can bake onto them without the media cracking. It's the same reason why the 3.5-inch floppies won out over the 5.25s, back in the day. And for that matter, the 5.25s won out over the original 8.5-inch floppy disks. And let me tell you what, those things were seriously floppy. Counterintuitively, as the diskette size shrank, the amount of data you could fit on a single disk went up, even with concurrent generations of the different sizes. And again, that media quality angle is why. As the platters got smaller, they got stiffer, you could put better and more media on them, and you could get a higher data density. It looks to me as though 3.5 inches is probably somewhere around the ideal for this type of technology, for the simple fact that once we hit that size, it really hasn't changed much. 2.5 inch hard drives, really the larger reason those got introduced was for laptops initially. And, then to the best of my understanding is the timeline progression is from there, they made their way into the data center. And they made their way into the data center because the smaller platter size meant that even though those drives were individually smaller and less power efficient and et cetera, you got a bit of a latency advantage on the shorter disks. It was kind of the equivalent of something we used to do called short stroking, 3.5 inch drives, where you would only use the inner tracks of the drive. You'd partition it so that you'd only be using the tracks on the inside. So it was kind of like making your own little 2.5 inch drive. And the reason for that is that when you have a really heavy random workload with a whole lot of seeks, the heads don't have to move as far if you're doing that. So you can maybe up to like halve your latency, depending on how hard you short stroke that drive. Now, when all you have available are rotational hard drives, and you have these really nasty, heavy-duty applications with lots of random access, it can seem very worth it to take a large hard drive and partition it way the hell down to short stroke it to get a latency advantage, or just to use physically smaller hard drives that are kind of effectively pre-stroked because they have smaller platters. But once SSDs hit the scene, now instead of talking about, well, maybe if I'm lucky, I can cut the seek latency in half, you can just freaking eliminate it. So the point in these really expensive, really hot, not particularly reliable, data density is terrible, enterprise 2.5 inch data center hard drives, well, it just went right out the window.
Yeah, there was also some advantage, especially in 1 and 2U machines, of possibly being able to pack a couple more drives in the one chassis. But I too had wondered in the past, could we make a bigger hard drive? Or even, why do they not make more 3.5 inch SSDs? Wouldn't it be better for cooling? And, my chassis are all 3.5 inch. Why don't they make more 3.5 inch SSDs? But it turns out it just isn't the efficient use of the space. And for hard drives, 3.5 inch seems to be the sweet spot. I imagine if we were super optimal, it would actually be some slightly different size. And it just happens this is a standard and is close enough. But now seeing they're even packing dual actuators into existing 3.5 inch form factor, I think we're not going to see anything bigger.
Now, what we might, in theory, see is the return of the full height 3.5 inch drive, which, if you're old enough, you may remember those things. Those things were tall enough to completely consume one of the big 5.25 inch bays that were used for optical drives. The modern hard drives tend to be less than half the size vertically of those drives. You're still talking about 3.5 inch platters, but what you get out of this full height form factor is you can pack more platters into an individual chassis.
You're talking about the thinness of them.
Yeah, exactly. We're talking about if you look at the drive as it sits flat on a tabletop, it sitting up taller on the tabletop, essentially. So it's still a 3.5 inch drive, but with room to stuff more platters inside. Because remember, there's more than one platter in a hard drive. Whether you're talking about the 3.5s or even the little 2.5s, you've got multiple platters in there. Typically, you're looking on at a 3.5 inch drive, you're usually looking at 9 platters in a chassis right now. So if you went to a full height chassis, you could potentially go up to, 15, 18, maybe 20 platters, who knows? The question is just, is that really worth it? And it looks very much like the answer is no, it's probably really not worth it. And the advantages that you might get in terms of maybe a little bit more efficiency because you have fewer power supply connections and, you can share more components with a single chassis, yada, yada, yada. There's trade-offs with that. And then also now, like in the very systems that you might want something like that, now that means that when a drive fails, it is a bigger chunk of the capacity of what you can cram into that machine to begin with. It also would mean yet another form factor for everybody's manufacturing lines to keep up with. Well, do you want your storage server to have 2.5 inch bays for SSDs or those, crazy 2.5 inch hard drives we were talking about? Or do you want it to have 3.5 inch bays for normal sized hard drives and put big rust in there? Or, now, well, do you want to add yet another form factor for super big and tall 3.5 inch drives that wouldn't fit in a standard size cart? And it seems fairly clear that if we haven't done that by now, it's because the advantages just absolutely are not enough to outweigh yet another form factor to deal with, yet another set of manufacturing lines for everybody, for For chassis manufacturers, for the hard drive manufacturers, for people making external caddies, you name it. It's another thing to keep up with.
I wonder what's so special about 3.5 inches, because floppies settled on 3.5 and hard drives have settled on 3.5. Because I remember I had an Amstrad that had 3-inch floppies and that never took off. Is there some physics reason that 3.5 inches is just like the perfect diameter?
Well, I don't know that 3.5 exactly is, and it's entirely possible that your Amstrad's 3 actually was the platonic ideal. But it's not so much like a point, like you've hit the exact point where it's perfect. It's more of like there is an ideal range. And I suspect that 2.5 inches and 3.5 inches are both within that ideal range of platter width. Because if you get the platter too narrow, you can't fit enough stuff on it, period, because there's just not enough tracks. If you get it too wide, then the platter is too flimsy, so you can't put really stiff media on it, or the media will crack as the platter flexes, so you can't get good density. It looks to me like 2.5 inch and 3.5 inch are both pretty much in that ideal space. And I say that because the sizes available between the 2.5 inch drives and the 3.5 inch drives, they don't seem very different in terms of data density. You have shorter platters and you have fewer platters in the 2.5 inch form factor, and the ratio of that to the width and the number of platters you get in a 3.5, it seems to me that it means the data densities are about the same per inch between those two. So then at that point, you're left with, well, why 2.5 and 3.5 versus your Amstrad's 3? And it just boils down to some manufacturer with a product in that ideal range somewhere cornered the market. Now, we happen to know who that manufacturer was. That was IBM, and the way they cornered it was because they licensed the PC for people to build PC compatibles, and it built this entire gigantic, beautiful bazaar of a market that we're all still benefiting from many, many decades later, although it's slowly going away as the whole industry moves back to these silos of largely wildly incompatible devices, like all the different, ARM Android phones that technically run the same operating system, but that you can't change parts. There's no universal drivers. You can't have like a universal image, which reminds me very uncomfortably of the 70s and 80s prior to the PC and the PC compatible explosion.
Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember that for various amounts on Patreon, you can get an advert-free RSS feed of either just this show or all the shows in the Late Night Linux family. And if you want to send any questions for Jim and Alan or your feedback, you can email show@2.5admins.com. Jono writes, I have a WireGuard tunnel to a family member where we share parts of our home NAS so we can do offsite backup to each other. I would like to do something like this with a group of friends, let's say 10, where we all contribute some amount of space to the pool and back up to each other. Is there a system that already exists that does this and spans out backups intelligently? Should I smash something together like ZFS, IPFS, and BitTorrent? If not, I may develop one, but it's going to be a gnarly project. Encryption, administration, redundancy, flaky connections, etc. This sounds like massively overcomplicating something that could be pretty simple.
I don't know there's a simple way to do it with that many people. Any distributed system of this size gets really complicated really quickly. Probably the closest thing you could get is some kind of object storage with erasure coding, but all of those systems are really designed with kind of performance in mind and assuming that you're going to have a bunch of powerful boxes backing it up, not a bunch of random people's home NASs at the end of various shoestrings of internet, and trying to make sure enough copies of everybody's data exists on enough different people's computers, so if one of them is off, you can still get your data back, or if one of them dies or explodes or whatever. The level of redundancy you have to make sure that all 10 people's data exists on at least 4 of the other people's machines or something to make this work would get very complicated very quickly, and just maintaining it as it constantly shifts is not what most object storage type systems are built around. And anything distributed like a Ceph or anything like that is really not meant for that kind of a bunch of different shapes and sizes and coming and going all the time, rather than just we built a rack full of machines to distribute this file system across because we needed more space or performance than we could get out of one machine.
But what if of the 10 people, you just all nominated 2 friends each and just bodied up into groups of 3 or 4?
Yes, that's the way to do it. You literally just have as many backup buddies as you need to. Maybe you feel okay with one offsite backup, in which case you need a backup buddy. Maybe you feel like you need two at separate sites. Well, in that case, you have two backup buddies. And the easiest way to manage that is just to make it reciprocal. Say, well, I would like you to back up 10 terabytes of my data. So, here is either a 10 terabyte drive or enough money to buy one. If that friend already has enough space, it's like, well, I don't need your drive. Give him enough money to make up for it, or it goes back and forth. Or if you both have the equivalent amount, then you can just take care of it that way. But this is an example, in my opinion, of humans trying to solve a human problem in really complex technological ways when it's very simple as a human problem. So just leave it human.
Yeah, there is a technological aspect. You need to send the snapshots off to each other and, pre-seed them on your own box and get together and everything. But ultimately, it doesn't need to involve IPFS and BitTorrent and, ridiculous shit like that.
Yeah, Lord, no. As far as the backup mechanism, I mean, we can talk about that all day long, but that is going to be a human problem because you need to convince all of your backup buddies to let you back up the things the way that you want to back them up. That's a human problem. We can't solve that with technology because both of you have to agree on doing something in each other's homes.
Yeah, I suppose some might be ZFS, some might be rsync or whatever.
Well, and also just how many of those 10 people have an off-the-shelf NAS and don't know how to do backups properly or use rsync or ZFS. And so while they have the space they'd be willing to give you, they don't really have a system they could give it to you on in a sane way. And just orchestrating the networking, like even just doing WireGuard, you need to use something a bit different in order to get all 10 people cross-connected correctly. Because WireGuard is really about point-to-point, not this kind of mesh.
Yeah, you'd really ideally want something more along the lines of Nebula. If like all 10 of you needed to be able to get into all 10 other people's stuff the same way, Nebula works really well for that.
And at some point, is it not easier to get all 10 people to put their money together and rent a big dedicated server somewhere with all the hard drive space and just all back up to it?
Pretty much.
It's maybe not as many different locations, but it's probably a lot faster and a lot more reliable than a bunch of people's home internet.
Yeah, if there's 10 of you, you could easily rent 2 boxes, like different sizes of the world, potentially.
Mm-hmm.
It occurs to me that honestly, given that somebody else has already broken the ZFS cherry on this episode, if we're presuming everybody's willing to use ZFS, probably the easiest way to do all this, like in a really simple way, is all 10 of you just club up together to buy one account at rsync.net with the ZFS service, and you all do your replication to separate data sets on that one pool that you've clubbed your money together for. If you don't trust each other with each other's data, you can even get fancy and do encrypted raw send, and nobody can get at anybody else's data, even though you can touch the binaries. They're encrypted with a key that you don't have, so that ceases becoming much of a concern.
So you just have multiple data sets all encrypted separately?
Yes. Now, in that case, we would be actually reversing my usual InfoSec advice, which is always pull your backups, don't push. Because in this case, if you say, well, I have 10 friends that are all using this thing, and I don't trust them enough to potentially be able to see my data in a usable format, then you also don't want them to be able to shell into your box from the rsync.net box. So in this case, rather than having the rsync.net one pull from all of you individually, you each are individually pushing to it, because rather than being the most secure, it is a definite avenue for potential attack, because somebody compromises that, then they would have access to all 10 of your boxes if you're letting it pull rather than all of you pushing to it.
In which case, if one of your friends gets compromised, then the whole thing potentially gets compromised.
Or if, one of your friends just kind of tends to be a jackass after he's had too many beers.
Yeah, but the point of this is that it is an offsite backup and is not your only backup.
Right. And, past a certain volume of data, that doesn't really make a whole lot of sense either. Once you've got more than, well, really just, I guess, what's the minimum now to rsync.net? 6 terabytes? Like, if you've got 6 terabytes of data, then there's not a whole lot of value in 10 people clubbing up, because you each might as well just have your own accounts. But if there's a lot of you with relatively picky unit amounts of data to back up, then that could make quite a bit of sense.
Right, well, we better get out of here then. Remember, show@2.5admins.com if you want to send any questions or your feedback. You can find me at joelrest.com/mastodon.
You can find me at jrs-s.net/social.
And I'm at Alan Jude.
On x.com.
Blue Sky.
See you next week.